Hello, everyone, and welcome to the next lesson. Today, we're going to graph quadratic functions. So, last time we learned about standard form and vertex form and factored form and all of the good information that each form tells us, whether it be the vertex or the x-intercepts or the y-intercept. From each form, we can tell whether it opens up or opens down. And today, we're going to take important information and determine how to graph the parabolas. Now, first, going to do more factoring practice. We're going to get really good at factoring. Factoring is coming up very soon. It'll be the next lesson where we need to do factoring and solving. And then I also want you to make a graph of y equals x squared. Make a complete graph. So scale, axes, do it on graph paper, make it look pretty, and we'll analyze that. Pause the video, take your time, answer these warm-up questions, and then we'll get started. Okay, so first one, we pull out a GCF, we got a grouping problem, and we can factor by grouping. Second one, we would try Xbox, but no two numbers multiply to 10 and add to 9, so not factorable. We have to be accepting of the fact that that can happen, but we need to know why that works. So the Xbox doesn't work, not factorable, so can't factor it. And then the third one's a difference of squares problem. We know it's a subtraction. We know the square roots of the first term and the last term, so 5 minus 2x, 5 plus 2x. Now we should focus on what y equals x squared looks like. So maybe you made a table. Maybe you just knew what it looked like. Your parabola, it goes through 0, 0. If I put 0 in for x, I get out 0 for y. If I put in 1 for x, I get out 1 for y. 1 squared is 1. Negative 1 squared is also positive 1. So I have 0, 0. I have 1, 1. I have negative 1, 1. And I have 2, 4. And I have negative 2, 4. Now this is what we call a parent graph. This graph hasn't been moved left or right, hasn't been stretched, hasn't been flipped upside down. It's just the basic graph of x squared. We're going to have to use this idea of a graph today when we see more complicated equations that have x squared in them. Everything we graph today is going to be a parabola, but it might be shifted up, or it might be stretched, or it might be upside down, could be moved left or right. And we're going to figure out how do we know. So, same vocab as last time. Vertex and stretch factor. Does it open up or down, the concavity? What are the x-intercepts? One we're going to add today is the line of symmetry. Okay, line of symmetry is that vertical line that cuts a parabola in half. There will be questions that ask, where's the line of symmetry? So we still have our three forms. I would recommend adding notes to the pages where we had the standard form, the vertex form, and the factored form. If you need more space, please use graph paper when we're graphing today. We want these to be accurate, precise, and detailed. So we'll start like we normally do with standard form. Okay, these are the same notes from last time. The y-intercept is 0c. We can find the vertex by doing negative b over 2a, and then taking that x value and putting it into the function to find the y. We could tell the vertical stretch, which is a, it tells us it opens up or down. And today, the vertical stretch, what it is going to be really important because it's going to help us graph some other points. And then if it asks to find the discriminant, that'll help us find out how many intercepts we have. So standard form, we can find a lot of information about a parabola, but the really important stuff we need is we need information for how to graph it. So think about, if I told you to graph a parabola, what is the most important information you think you'd want to know? Now, I hope you said, well, the vertex seems really important because that is the most important point on every parabola. Okay, the maximum or the minimum. The other important point or important piece of information is the stretch, the vertical stretch, the A value. Because if I know the vertex and I know whether the graph opens up or down, I have a lot of information. So let's look at this example together. So from this equation, I want to find the vertex and the vertical stretch. If you want to try to do it, pause the video now, try it out, and then see if your vertex matches with ours and if your vertical stretch matches with ours. Okay, let's take a look at what we got. So the vertex, remember we can do the x value is negative b over 2a, which gets us negative 20 over 4, which is negative 5. And then I can put negative 5 into the equation and get the y value. So I put f of negative 5, negative 2 times negative 5 squared, plus 20 times negative 5, plus 43. Get out negative 7, and you should try that. Check that you can write it down. Check that you can do it on the calculator, not just watch the video and say it looks good from the video. Now the A value is right here. So I know it opens up, and now I'm going to show you how this 2 works. Okay. So you need to start at the vertex when we graph. Graph that point first. So graph negative 5, negative 7, which I already did down here on the graph. Right here is my vertex. Now we got to remember back to the warm-up, where the warm-up, if it's just y equals x squared, we go left 1 and up 1 because we went 1, 1. Now the vertex, the vertical stretch is going to tell us how much to go up. So now we go kind of like slope. We go over 1 and we go up 2. And we plot a point. And same thing both ways. Now you don't need to make the dots. You need to go right 1, up 2, and it's symmetric. Okay, the line of symmetry is right here. So we start at the vertex and we go the same verticality in both directions. So left 1, up 2, go back to the vertex, right 1, up 2. Now 3 points is all you need. So you can go over 1, up 1, okay, in both directions. You could also go over 2, up 4. So if I start at the vertex, I can go left 2 and up 4. 1, 2, 3, 4. Okay, 1, 2, 1, 2, 3, 4. Except now it tells me to double that. So normally I'd go over 2, up 4. But since the vertical stretch is 2, I go over 2 and I go up 8. So left 2, up 1, 2, 3, 4, 5, 6, 7, 8. And then go back to the vertex, right 2, up 8. So if I want 5 points, I can have 5 points as well. 3 points is the bare minimum, though. The vertex and 1 point on either side. My line of symmetry is x equals negative 5. It's the vertical line that goes through the vertex of the parabola. It's at the x value of negative 5. So to graph from standard form, you need the vertex, and you start at the vertex, and then the vertical stretch will tell you go left 1, up how many. Now, graphing form. We remember graphing form gives us the vertex and gives us the vertical stretch. We can find the y-intercept from it. And this one is super nice to us because it gives us the two pieces of information that we just needed in the previous problem. So we graph this the same way as we graph in standard form. We need the vertex and we need the vertical stretch. And the equation tells us the vertex and it tells us the a value. So in this case, the vertex, remember, it's the opposite sign of the middle number, and it's the same sign as the outside number, so -5, -8. We know it opens down because there's a negative a value, and it's vertically compressed. It's actually going to be a wider graph. So let's see what that looks like and how we can figure it out, how we can graph some points. So now I have no idea why I started at -5, 4. I think I meant to put +4 in the equation, so we're going to do that. We're going to cheat a little bit. Now, like last time, we can go left 1 and down 1/2 because my vertical stretch is 1/2. I go left 1 and down 1/2, but I don't like to do fractions. So the normal parabola, y equals x squared again, was right 1, up 1, right 1, up 1, right 2, up 4. Now in this case, since the a value is -1/2, I can go right 1, up 1/2, or down 1/2 because it's negative. And then I can go right 2, and normally I'd go down 4, but now I do half of that. So my a value tells me do half the height of what I normally do. So 2, down 2. Left 2, down 2. And I start with the vertex. I got 3 nice points. If I want more nice points, I can think of the original graph. It would normally be right 3, up 9, because 3 squared is 9. So now I can go right 3 and down half of 9, which is 4.5. So if I go right 3, 1, 2, 3, I can go down 1, 2, 3, 4.5. But I don't need to. I just need 3 points. So vertex form. If I know the vertex and I know the stretch, I can graph it. Now I can do this. It's going to take practice with the stretch. So you're going to do some practice at the end. And then once again, if it asks me for my line of symmetry, it's x equals -5 because it goes through the x coordinate of -5. Now, factored form. Factored form, I would say, is the one that's challenged me the most when graphing it. Because this is different. You don't start at the vertex. So we remember that factored form tells us the two x-intercepts, and we found the vertex from the x-intercepts, where the vertex was in the middle of the two x-intercepts. So in this case, the question is still, how do I graph it? What pieces of information would help me? Now, since you can find the vertex after you found the x-intercepts, we're going to use those 3 points. You need to know the x-intercepts and the vertex. So let's look at this example. Okay, the x-intercepts. We set each factor equal to 0 to find x equals 0, so 0, 0. We set the other factor equal to 0, and then we have x equals 4 when we solve it. We have 4, 0. And we learned last time that the vertex is in the middle, so what's in the middle of 0 and 4? Okay, we know that 2 is in the middle of 0 and 4, and then you put 2 into the equation, So -2 times 2, 2 minus 4, do all your multiplication, and you get 8. And just to make sure we're doing this right, our a value is negative, so it should be up and down. Now we can graph 0, 0, 4, 0, and 2, 8. We can graph those 3 points. And if I want to check to see does this graph look right, the vertical stretch tells me to go left 1 and down 2. So start at the vertex, go left 1, down 2, go left 1, down 2. Now I don't need those 2 points that I just plotted. I need 3 points. So in this case, I have the x-intercepts, and I have the vertex. Those are 3 good points. The negative tells me the graph opens down. This graph looks like it's opening down, so I'm confident that I graphed it correctly. So factored form, the 3 points that I would use, the vertex and the 2 x-intercepts. For the other forms, I would find the vertex and then use the stretch to find 2 other points. To graph a quadratic, you need 3 accurate points. The vertex has to be one of them, and then you have to pick a point on either side of the vertex. Now, if this problem asks what the line of symmetry is, go ahead, pause the video. Tell me what you think the line of symmetry is. Okay, I heard everyone yelling at the video. They said, okay, we know that the line of symmetry is right down the middle, and that equation is x equals 2. So you said that. Sounds good. All right, we got this. Now, you pick some of these, all of these, as many as you want. You pause the video for as long as you need. I see one in factored form down here. I see one in standard form up here, graphing form, another standard form. Some have positive a values, some have negative a values, some have vertical stretches. I would recommend you graph as many of them as you want. You practice as much as you need. And that's how you get good at this. Now, in every single graph you have, I want to see the vertex. Every single graph you make, I want to see at least 1 point on either side of the vertex. So you have to have 3 good points on every graph. Your graph should be accurate. You may want to do more. You may want to find the x and y intercepts. Practice that. Write the equation of the line of symmetry. And when you're ready, unpause the video, and I'll spend a few seconds on each slide with each of these problems. Okay, so hopefully that video has been paused for 5, 10, 15 minutes. You've been practicing, you've been trying them out and seeing that you can do them. So the first one, you find the vertex using negative b over 2a, plug that in to find the y. My vertical stretch is 1, so left 1 over 1, up 1, right, go back to the vertex, right 1, up 1. If you want to go 2, 4, you can do that as well, because 2 squared is 4, and the vertical stretch is 1. Maybe you said the line of symmetry is x equals -3. Maybe you saw that the y-intercept is 0, 7. Concave up. The more details you can tell me, the more you understand quadratics and parabolas. Now let's look at a few more. This one is in vertex form, so the vertex is -1, 4. My stretch is 3, so left 1 up 3, right 1 up 3. Maybe you put 0 in for x and saw that you have the point 0, 7. That's the y-intercept. Line of symmetry, x equals -1, concave up, vertical stretch of 3. This one we don't really find the x-intercepts from. And in this case, there are no x-intercepts. Now we have one that's concave down with a vertex of 3, 6. Left 1 down 2, right 1 down 2. Here's some points. Check your graph. Okay, x equals 3, line of symmetry. Maybe it calculated the y-intercept. I didn't in this problem. But you can always check, does your graph go through that point? Does your graph open down? Does it do the details that you know it should? Another vertex form. Opens down to -1, vertical stretch of -1, so left one down one, right one down one. Hopefully as you do these, you become more comfortable and see, I can do these. I know what details I need to find. Back to standard form, so -b over 2a. Vertical stretch of -1, left one down one, right one down one. 0, -7 is the y-intercept. X equals -2 is the line of symmetry. Details, continued practice makes you great at these. And then factored form. So what makes this first parenthesis 0? -3. What makes the second parenthesis 0? +1. What's in between -3 and 1? Is -1. So if I put -1 in for x, I evaluate and get -8. So in this case, I didn't go left 1 and up however many. I found the vertex from the two x-intercepts, and I graphed the two x-intercepts in the vertex. From the graph, I could still tell what the line of symmetry is. If I wanted to put 0 in for x, I could still find the y-intercept. And you've already found the x-intercepts. So hopefully now you understand you can find 3 points for a parabola, one of them definitely being the vertex. You know how to tell me whether it's concave up or concave down. You know how to use the vertical stretch, and you know how to find the equation of the line of symmetry, the axis of symmetry. So continue practicing these. Let me know where you have questions, and we'll keep graphing so that we can do the next lesson, which is applying situations to graphs of quadratics.